Hello, hi everyone. Good morning. My name is Nehel and welcome to the stream by OneClass. Today we'll be covering math questions. These questions range anywhere from university to high school level questions, and we'll be covering about 10 to 12 questions, time permitting. So just a little bit about myself. I went to University of Waterloo and studied mechanical engineering from there. I graduated in 2018 and have been working for the past 2 years in the plastics industry as a project engineer. The next thing for me is I'll be starting my master's degree at U of T, also in mechanical engineering from January. So yeah, really look forward to that. Okay, without further delay, let's get into it. Okay, so the first question for today is prove using a Venn diagram A union B intersection C is equals to A union B intersection A union C. Okay, so we're given this Venn diagram. I'm just gonna copy this over. There we go. Okay. So the question is asking us to prove. I'm just gonna write the left-hand side term first. So for question one, the left-hand side term is A of union B intersection C. Okay. So just to recall, this U means union, and the inverted U means intersection. Okay, so we're given three sets here, A, B, and C, and they have some overlap, so they have some intersections, and we need to find this area A intersection of B, A union of B intersection C. So we'll start off by the term in the bracket, which is B intersection of C, and we'll try and identify that. So this term here is this set here is the B set, and this is the C set. Their intersection will be everything which is common between their two. Okay, so their intersection would actually be all of this portion would be the intersection. Okay, so that what I've identified here is B intersection C. Okay, I'm just gonna mark that down. This here is nothing but B intersection C. Okay. Now, if we look outside of the bracket, we're given um, another requirement, which is to take the union of this intersection with A. Now, the union of this intersection with A would include all of A, essentially, plus this. That's the easy thing about union is you can look at the union of two sets as just including both of them. So here, our first set is B intersection C, so we'll include that. And our second set is A, so we'll include all of it. So now if I were to quickly highlight that for you as well, I'll do it in a different color just so it's easy to tell. So this, all of this, even the parts which are, let's say, not exclusive to A and are shared, will also be highlighted because, again, they're part of the overall set A. Okay, so this, what I've highlighted is all of A. And then since we're taking the union, our final answer is actually the two colors. Okay. So here what we have is this is A union of B intersection C. Okay, so just to clarify, it's both the blue shaded and the yellow shaded region is the overall, let's say, final set we would get from this operation. Okay, so that's what the left hand side looks like. If we go over and check what the right hand side would look like, so I would paste another one of these. Okay, so on the right hand side, we're given two brackets, so we'll solve them individually and then combine them. Okay, so let's see, we're given A union B intersection of A union C. Okay, so A union B, again, with the unions, all you have to do is consider both sets and just use all of them. So what I'm going to do is I'm going to quickly show you what that would entail. So all of it, so this is all of it up till here. Okay, and then union of all of B. Let me just shade all of this so it's visually clear to you what A union B would be. Again, I'm just solving the first bracket for now, and then we'll solve the final um, operation and do it for the other bracket as well. So this I've covered all of A, and then the first operation is asking us for A union of B. So that would also mean that B is also all covered. Okay. 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 So this would be our A union of B. Union of B. Okay, well, it doesn't let me write on top. So this A union of B. Okay. So next up, we need to find what's A union of C. So I'm going to use a different color and do it just right below it so you guys can see. Okay, so A union of B again is all of A plus all of B. So that would be nothing but all of A is this and all of C is this. So if we were to highlight that as well. Oops. Okay, so we've got all of A and all of C. Okay, so that's the final result from this other operation in the bracket. So now that we have done both the operations, what we can do is we can do the final operation and then identify what the answer on the right hand side is going to be. So this is equal to A union C. Okay, so now if I'm looking at these two and if I need to take the intersection of them, I can clearly see that all of A, since it was in A union with other sets, A stays intact. We're not doing anything to A, we're using all of A. Therefore, the final answer on the right hand side will include all of A. So it would have all of your set A. Plus, you're looking at anything common between this portion here and then this portion here, which is nothing but this overlapping region which we had drawn. Therefore, if I were to look at both of these and just get a final answer, that would be nothing but, I'm just going to do it in black. So again, that would be nothing but all of A. Looks like I can't do that. So we've essentially done a lot of interim steps just to make it visually more clear. You can do it in 1 2 steps as you like. Okay, so again, we when we look at the intersect of the 2 Venn diagrams we drew up top, their intersection would be all of A, and then it would also include this stretch here, which is nothing but what we had initially. Okay, this and this are exactly comparable. Therefore, we have proven that. I'm just going to get rid of these two just so you know what we're comparing with. Okay. Never mind. It's not wanting to move over. Let's see. So essentially, this is the left hand side and this is the right hand side, and they're equal. They're both the same. Therefore, using the Venn diagrams, we have proved that this equation here indeed holds true. Okay. So we're gonna just go through the solution as shown here. So they have solved for the bracket force, which is B intersects C, which is this portion. Then the union of that with A is all of A plus B intersects C, which is the left hand side. And for the right hand side, we have A union B, then A union C, and then their intersection. So that's correct, and the both are the same. So the solution is correct. Okay. So question 2. Find the dimension of a rectangle with a perimeter of 112 whose area is as large as possible. Okay. So this is, we would need to use some differentiation here. So I hope you recall differentiation. So for question number 2, we need to find the area of a rectangle, and we're given its perimeter, but we're not given any of the sides. So what we can do is we can just say the sides are x and y. So the length is x and the height is y. Okay. So we're given the perimeter, and perimeter is nothing but the sum of all the sides. So in this case, it's 2x plus 2y, or 2 times x plus y is equals to perimeter. And we're given the value, so 2 times x plus y is equals to 112, or x plus y is equals to 56, since you can bring the 2 or divide both sides by 2. Okay, so that's our first equation. Okay, the second part asks us to maximize the area. Now, to maximize the area, we need to first get an equation for area in terms of the variables. So right away we know area of a rectangle is nothing but the length times the height. So in this case, it's x times y. Okay. Now, let's say we want to substitute one of the terms here. What we can do is we can solve for y here, which would make it 56 minus x. Actually, let's use this as our number 1 equation, and then in 2, this is our number 2. So we say in 2, sub 1, okay, which gives us nothing but area is equals to, on this side we are substitution for y, so it will be x times 56 minus x, or area is equal to 56x minus x squared. Okay. Now, to maximize this, we know that from essentially, if I wanted to describe to you how we get to the maximum, let's say if we have any function or and this is the curve of the function. Okay. The slope of the function is let's say sorry, this is f of x is equals to let's call it y. So here y is equals to some function f of x. Okay. To be able to get to the point of the maximum, which is somewhere here on the top, what we do is we look at the slope at each point of this curve. So the slope here, slope here, slope here, slope here. As you see, the slope here is increasing, so it's going in the upward direction, it's positive. Then it's increasing here, it's increasing here, it's increasing here slowly, but it's increasing. As it reaches the maximum, you can see that the slope, which is almost like a tangent line, is actually 0. It's parallel to the x-axis, so it's 0. And then after reaching the maximum, it starts to decrease. So it starts to change again. Therefore, from that, we should know that if we take the derivative of a function to get the maximum, the slope has to be 0. Okay. So therefore, if I take the derivative, dA over dx is equals to, and just a quick reminder on derivatives, if I have d of dx c, it becomes 0. If I have d of x times c dx, it becomes c, which is a constant. And then if I have d of dx x to the n, it becomes n x to the n minus 1. Okay, so in this case, we have on the right side derivative of 56x minus x squared. Okay, this slope has to be 0 again for the maximum. So we say 0 is equals to, and then this derivative becomes 56 minus, since it was a constant times x, it becomes 56, and then the x squared becomes minus 2x. And then if we solve for x from here, we get 2x is equals to 56, or x is equals to 28. Okay, and then since we have this equation, we can plug it back into the other equation which we had, number 1, which was y is equals to 58 minus x, I believe. And from that we can get the two variables. So the first equation was y equals to 58 minus x. Y is equals to 58 minus 26, which is equal to, 28. So it's 56. So y is also equal to 28. Therefore, it's actually not a rectangle, it's a square. So that's an interesting thing to note, that if you have given a quadrilateral, we can call it, or for any rectangle, to maximize the area, it actually has to be a square. Okay, let's go through this question and see. The perimeter P is given, area is x times y, and then from the perimeter we get one of the equations, we substitute. The derivative has to equal 0, so we get y to be 28. That's perfect. So key takeaway from this question is to remember how we got to the thought process of the derivative having to be 0 for the maxima, and just the regular expressions for area and perimeter. So the solution is correct. What does multiple in mathematics mean? So if I have a number, and if I can find a set of two numbers which by multiplying together I can get the original number, I can say that the two numbers are multiples of that number. So how I would define it is, given any number, let's call it A, if there are numbers B, C, it can be any amount of numbers. So for example, 8 can be said as 2 times 2 times 2, so there's 3, whereas 16 can be said as 2 times 2 times 2 times 2, there's 4. So it can be any number of numbers. So given any number A, if there are numbers B, C, such that A is equals to B times C times all the remaining numbers which we may have, we can say that B comma C and the remaining are multiples of A. Or you can look at it the other way as well. You can say A is the multiple of these numbers. Okay. So when you multiply the numbers of an integer, the resulting number is what we call a multiple. An integer is a whole number. So for example, if you give me 27, this means that 3 and 9 are multiples of 27. Okay. I hope that's clear. So the solution, oops. Okay. Next question, question number 4 for today. Find the measure of each angle. So we're given this diagram, and we need to find how this line intersects with these two lines and angles they form. Okay, so right off the bat, even though it doesn't explicitly state anywhere, we can tell that these two lines are at an angle of 90 degrees with each other. So I can say that over here, this is 90 degree. Okay, this angle is 90 degrees. And if there is a line which intersects these two lines, it does not affect their overall angle, and the angle it forms with the two lines actually add up to the total angle still. So from that logic, we can say that 2y plus 4y, which is this angle and this angle, if I were to add the two, I would still get my original 90 degrees. So this is nothing but 90 degrees. Therefore, we can say that 6y is equals to 90 degrees, and we can say y is equals to 90 over 6, which is 3 times 2, sorry, this is 45, and this is 3 and 15. Okay, so we got the value of y to be 50. Now with questions like these, even though they can be deceptively easy, we need to uh, look at what the question is asking for. The question is asking for find the measure of each angle. So even though we got the value of y, that is just the variable. We didn't get the value of the angle. So therefore, we can say that 2y is equals to 30 degrees, and then 4y is equals to 60 degrees. So the final answer in this case should be 30 and 60, not the y variable which we solved for, which we got to be 15. So just be careful here. Make sure you read the question when you're answering these, and you should be all set. Okay. So again, they've done. The answer is correct. I'm not going to take that away from them. They did the right thing, but I think it's really important that we find the measure of each angle. So it doesn't explicitly state that. So I'm going to mark this to be incorrect. So while the value of y is correct, the question states for the values of the angles which should be noted to be 60 and 30 degrees. These include these in the answer. Okay. Alright, so I'm going to mark this one as incorrect. Okay, question number 5. Okay, sorry for the interruption. Let's continue. The next question is actually a square root question. We need to find the square root of 196. So these questions are fairly popular, and you can see why. This even though this might be a perfect square, people tend to get confused in cases like 26 when it's not a perfect square. So how do we solve that? So let's get into it. Under root of 196. So the way we solve any square root question or a cube root or any particular um, question which has some power exponential in the fractional terms, we write the prime factors. So I'm going to start off by writing the prime factors of 196. So right away 2, we always try 2 to begin with. 2 times 98 is 196, and again we try 2, we get it, and we get 49. We tried 2 here, it doesn't work. The quick trick to see if 3 works or not is if you add them and you get a number which is divisible by 3, then 3 is indeed a factor, but in this case we get 13, and 3 is not a factor of 13, so we skip 3. 4 obviously won't work because 2 didn't work, 5 won't work because it doesn't end in 5 and 0, 6 won't work again because 3 and 2 didn't work, but 7 would work. So 7, actually 7 times 7 is 49, and then finally 7 times 1. So our prime factors came out to be this set here. Okay, so the best way to write this down is you say under root of 196 is nothing but square root of 2 times 2 times 7 times 7. Okay, in that case, we can actually square these, or so say that it's nothing but 2 squared times 7 squared. You can, just to simplify things further, if you have any terms a and b, this is nothing but square root of a times square root of b. So just using that, just to further simplify this, we can say that this term is nothing but under root of 2 squared times square root of 7 squared, which would give us 2 times 7, which is equal to 14. Okay. If you ever wanted to verify if the final answer you got is correct or not, you can do that. So 14 times 14, so this is 16, 1, 4, 5, 0, 4, 1. 196. So you indeed get 196. So every time you do a square root question, and it's easy to go wrong, you have to ensure that you do the prime factorization first. In case you don't find perfect pairs like we did in this case, you can just leave the pair as is and leave the one you didn't find a pair of as is, and take all the pairs and try to pick them outside of the square root to simplify. And then if you want to double check, what you can do is you can multiply the final number twice to make sure you got the question number. Okay, so we do the prime factors, that's correct, this is correct, 14. So the solution is correct in this case. Question 6. What is tan 0 equal to? So if I have a triangle, no, so I'm going to draw a triangle. Actually, no. Okay. So if I have a right angle triangle, such that this angle here is theta, this is the perpendicular, this is the base, and this is the hypotenuse. We often call this as the adjacent, this as the side, or opposite, I guess. Actually, so let's just use the regular notation. So perpendicular, base, and hypotenuse. We know that sine of theta is equals to perpendicular over hypotenuse. Cos of theta is equals to base over hypotenuse, and then tan of theta is equals to perpendicular upon base. Okay. So in this case, what we have to do is we have to find the value of tan of 0. So if you look at this triangle, essentially what you're doing here is you're reducing your theta. So if you just imagine, instead of this bigger theta, what you're doing is you're taking it down all the way to 0. So in this case, let's say this would be something like 20 degrees. You go even further down to 10 degrees, and then you to get to 0 degrees, all you be left with is a straight line. Okay, so this is the 0 degree angle. Now, in this case, the perpendicular actually does not exist, but you still have a base which is equal to any number in this other than 0, basically. Okay, so I have that visually here. So tan of 0 is actually equal to, the perpendicular no longer exists, so it's 0 over 1 or any number b, but we'll go with 1. So tan of 0 is actually equal to 0. So in this case, they have set tan of 0 is equal to undefined, which is actually not correct. Okay. What is the additive property of equality, inequality, and the additive inverse property? So the additive property of equality states that if you have an equality, let's say 3 equals 3, if I add a number on either side, the equality still holds true. Okay, so okay, I'm gonna do is just gonna type it down. Okay, so the additive property of equality states that given an equality, let's say 3 equal to 3 or 2 equal to 2, if I add a number x to either side, the equality still holds true. Okay, so basically what I mean by that is 2 plus x is actually still equal to 2 plus x. Okay, this should be fairly intuitive, I hope. Just sometimes remembering the overall definition can be a bit challenging. So if this is true for any number, not just 2, any number, if you add something to either side of equality, the equality still remains true. Okay, and the similar applies for inequality as well. So if I'm just going to continue typing here, so this holds true for inequalities as well. You can add a number to either side of an inequality without affecting. So what I mean by that is if I have an inequality, let's say 3 is greater than 2, which is true obviously. If I were to add x on either side, my inequality would not change. So if I had 3 plus x, it would still be equal to 2 plus x, which again should make sense. Let's say x is equal to 1. So this inequality would not be affected by the addition of any number. So that's the additive property for inequalities. And then the question also asks for what is the additive inverse property. So the additive inverse property states that if I add a number, if I add the negative of a number to itself, the answer is 0. So when the negative of a number is added to itself, the resulting number is equal to 0. Okay, so that should again be fairly intuitive. Let's say if I have 3 and then I add minus 3 to it, obviously that's 0. Okay, so those were the three equalities and their definitions. Let's see what we have described here. So for example, 5 plus 3 is 8, perfect, 20 is greater than 3, 10, and we add 3 there, so it doesn't do anything, that's perfect. And then x plus of minus x, actually that's a very good way of representing it, since it's an additive inverse. What you're doing is you're adding the inverse of it. So adding negative 3, which is equal to 0. Perfect. Okay, so in this case the answer is correct. How do you write 65% as a fraction in simplest form? Okay. So 65%. So step 1 is I need to remove this percent sign. So the way we can do it is to remove percent sign, divide by 100. Okay, so basically 65% becomes 65 over 100. So we in theory could leave the answer here, but the question explicitly asks for fraction in simplest form. So we can see if we can simplify this further, and we'll look for any common factors. So 2, even though it's a factor of the denominator, it's not a factor of the numerator. 3 is not a factor of either. 4 is not a factor of 65. 5, however, is a factor of both. So what we can do, this becomes 20, and this becomes 13. And these no longer have any common factors, so what we can do is we can say that 65% is nothing but 13 over 20. Okay, so given any fractional questions, what you do first is you remove the percent sign, and then you look for any common factors between the numerator and denominator, so you can get it to the simplest form. So percent sign is removed, then you divide both sides, so we find 5 as the common factor, and then you get 13 over 20. Perfect. So the solution is correct. Okay. What is 90 degrees in radians? So the way we do this question is, if I have a circle, the way I remember these radian questions is as follows. If I have a circle with a center O, I know if I were to go around the circle, then my angle of revolution would be 360 degrees, because that's the angle inside the circle. This is actually equal to 2 pi radians. Okay, so since we're given that, what we can do is we can say 1 degree is equals to 2 pi over 360 radians, and then 90 degrees would be just the product, 90 times 2 pi over 360 times 90. This becomes 180, and this becomes 102. So therefore, -90 degrees is equals to pi over 2 radians. Okay, so to recall, the way I solve this question is I quickly put together what the identity would be, and if you're having troubles in remembering this identity, what you can do is draw the circle. You already know that the angle within the circle is 360 degrees, which is also equal to 2 pi. So all you have to do in this case is remember that 2 pi, 360 would come intuitively, and you can get the answer by then multiplying the required angle in degrees to the equation. So 90 degrees is indeed equal to 2 pi radians. So this answer is correct. So next up, question number 10. Excuse me for a second here. Alright guys, let's get back to it. Okay, so question number 10 for today's session. What is the square root of 145? So we have another square root question. So the first step for any square root question is you find the prime factors. So in this case, we'll start off by finding the prime factors of 145. We always start with the number 2, and we know right at the back that since the number at the ones place is not an even number, it's not divisible by 2, we try 3 next. So we sum the numbers and see if that number is divisible by 3. So in this case, we get the sum to be 5 plus 4 is 9, 9 plus 1 is 10, which is not divisible by 3. So 3 is also not a factor, 4 is also not a factor, but 5, however, is a factor since this number ends with a 5. So we can say that 5 times, I'm correct, 5 times 229 gives us the number 125, 145. And then to factor 29 further, we can see that again 2, 3, 4, 5 won't be a factor, neither is 6 and neither is 7, which kind of tells us that this add number actually has no further factors which we can identify. So therefore the next factor for 29 is itself, which is 29. So we get these two to be our prime factors. So therefore under root of 145 is nothing but square root of 5 times 29, and we can't really simplify it any further. If we wanted to, we can plug it into a calculator, and if let's say if we find it easier, we can write this as under root 5 times under root of 29. However, that's the extent of the solution we can get in. So since this number cannot be simplified further, you can use a calculator. This is perfect. So this answer is correct. Okay. Question 11. We have another square root question. What is the square root of 1600? Okay, so 1600, this would have a long factor tree. So what we can do is we'll do something interesting here. So instead of factoring 1600, which is somewhat of a big number, let's do it this way. In the previous examples, what we have done is we have said that if I have one square root of a, and if I can also write this as square root of b times c, or square root of c, as long as a is equals to b times c. So you agree with that? So right at the back, what I can say is 1600 is nothing but 16 times 100. Okay. So now if I do the prime factorization of 16 and 100 individually, I should be able to get to the same answer as if I did the prime factorization of 1600, which would have been a bit longer. So what I can do is I can start with 16 here, then on the other side I will do 100. Okay, 2 is a factor obviously, so 2 times 8, again 2, again 2, and then again 2. So these are the factors in this case. And then for 100, we'll do the same thing. So 2 and 50, 2, 25, 5 and 5, and 5 and 1. So we got the prime factors for both 160, 16 and 100. So these prime factors were all of these. Okay, therefore we can say that under root of 1600, which was equal to 16 times 100, is equal to 2 times 2 times 2 times 2 multiplied by 2 times 2 times 5 times 5. Now the other thing which had splitting the question this way helped us with is that not only did we save a few steps by not doing the prime factorization of 1600, it would also have been much more confusing to find and identify all the pairs. Whereas in this case, the pairs are fairly easy to see. We can see that there's 2 pairs here, which makes it 2 squared times 2 squared multiplied by, and then there is also 2 different pairs here, so we get 2 squared times 5 squared. So therefore this becomes 2 times 2. Let's actually do it. So what you can say from that is this, you split them. And then 2 squares under root is nothing but 2 times 2 times 2 times 5. So that should be a final answer, which should be equal to 4 times 10, which is equal to 40. Therefore, square root of 1600 is equal to 40. Okay, so next up, we'll do the next question. Just let's verify. So they've done it a similar way actually, which is nice to see. 16 times 100, and you split them and you get the answer to be 40. So the solution is correct. Okay, so next question, question 12. Which operation could be performed in order to find the number of milliseconds in a year? Okay, so this is a conversion question. What we are given is we need to go from year to milliseconds. Okay, so what I can do is I will do it in the units form. So the way we do that is we type 1 year, and I will have to multiply this number by a factor such that we can go from 1 year to days. So I know that in 1 year there are actually 365 days. Okay, now that we've gone to days as our final unit, we can go from days to hours. So we get in 1 day we have 24 hours. Okay, so now we're almost there. In 1 hour we have 60 minutes. Okay, I'm going to continue it in this line below. Every minute has 60 seconds. Okay, and then we know that 1 second is equal to 1000 milliseconds. So I'm just going to say mass. Okay, so the advantage of doing it this way is you can clearly see the units cancel out. So year goes with year, day with day, hour with hour, minute with minute, and then second with second. And in the end, all you're left with is milliseconds. Therefore, your final answer should be 365 times 24 times 60 times 60 times 100, 1000. So the key thing to note here is the 1000 at the end. Make sure you're not just getting 2 seconds and you're actually converting fully to milliseconds. So looking at the options here, the answer would be B. B would be the correct answer. So therefore, B is the correct answer. Okay, let's see what they have done. So similar conversion, and then the answer is B. Perfect. So the solution is correct. Okay. We've actually now reached the end of the stream. Thank you so much for joining today's stream. If you found it of any value, please feel free to drop us a like, a comment. If you have any questions, and feel free to subscribe to our channel as well. We do these tutorials / question answer sessions very frequently, so I'm sure we can add a lot of value. And also feel free to check out the link in the description if you have any further questions. Awesome. Thank you so much for your time, and have a great day. Take care.